Hi, everybody. Happy Wednesday. Half of the week has gone by, and today let's start off with our Thinkogram. So let me go to share my screen and our hover cam, and here is the Thinkogram for today. Look carefully. It's something I love to drink, especially in the summertime. Lem in the word aid, lemonade, lemonade, yum, yum, yum. All right, darlings, so today's lesson, let me stop sharing here. Today's lesson is kind of what we did yesterday and building onto it a little bit. But again, I think if you know your multiplication facts, which many of us do, this lesson will be easy schmeezy for you. So if you would have your notebook out or a piece of paper, or if you did print these pages out. We're going to start them right now. So right now I'm going to do page 30. So let me put that under my Mio here and share my screen once more. There we go. So we are on page 31st. We're going to do page 30 and also page 32. And your homework is on the next link, which is pages 33 and 34. And I will have the answer key up also for you to check your work before you come back to school tomorrow. So we are ready to go. Okay, kiddos. So let's start up at the top. So what we're going to do today is basically take the two digits that you see available to us that aren't zeros, and we're going to multiply them. And then whenever you multiply these zeros or these numbers with all these zeros, you just count all the zeros that are at the end, and that's how many zeros you put at the end of your answer. Okay, so it says use mental math and a pattern. So all we take is just 3 times 4, and that equals 12. And we count up all the zeros and just add that many zeros to the end. And that's what 30 times 4,000 will equal. So we count 1, 2, 3, 4, 4 zeros total in both of those numbers. So we have to add 4 zeros to the end. So our number or our answer is 120,000. And it says here, what basic fact can help you find that? Well, we just take the 3 times 4 and that equaled 12. That's the basic fact to help us because everything else after that, you just add zeros to it. And that is our lesson for today. How easy is that? Okay, so kiddos, let's use mental math to complete the pattern. We remember from yesterday what 10, whoa, come on and focus. 10 to the first power means a 1 with 1 0. So that's just the number 10. Okay, so 1 times 10 is 10. Or we just take this 1 and write it down, and the exponent 1 tells us how many zeros to write. Remember that from yesterday? So here, 1 times 10 to the second power, that's a 1 with 2 zeros. So that means we just copy down this 1 and add 2 zeros to the end. So, of course, it's 100. 1 times 10 to the third power, we copy down that 1 and we add those 3 zeros to the end because this is the number 1,000. So 1 times 1,000, of course, is 1,000. 1 times anything is that other number. Okay, over to number 3. It already tells us that 7 times 8 is 56. My dog Archie, he does tricks. 7 times 8 is 56. I'm sure you've heard that before. So now they're saying, hey, if I put 7 times 8 here and do that first, then I have to take it times 10 to the first power, meaning I just add 1 0 to the end of 56. So 7 times 8, we write 56 and add that 1 0. That exponent 1, when it's attached to the number 10, means just add 1 0 to it because that is the number 10. Anything times 10, you just add that 1 0. 7 times 8, 56. 10 to the second power means, hey, add 2 zeros to the end of me, and it's 5,600. 7 times 8, 56. And here we have to add 3 zeros because 10 to the third power means you're multiplying it times 1,000. And anything times 1,000, you just have to put those 3 zeros in the ones, tens, and hundreds place. All righty, here we go to number 4. 6 times 5 is 30. Okay, now we have to be careful with that because if 6 times 5 equals 30, and let me write that for each of them, then 30 times what power of 10 would equal the number 300? Many kids say, oh, there's 2 zeros here, so it's 10 to the second power. Not in this answer, because look, 5 times 6 is 30, and how many extra zeros are there? Only 1, so it's 10 to the first power. That means 1 0, or multiply it by 10. Here 6 times 5 is 30 again, so let's box out the number 30, and let's see how many extra zeros we have. 2, so that's 10 to the second power. Those 2 zeros mean the number 100. And that's 10 to the second power. Let's go to the third one here. 6 times 5 is 30. Let's box out the number 30 and see how many extra zeros we have. 3. So that means that it's 10 to the third power, or the number 1,000. Okay, you're catching on? I'm assuming this is easy stuff, right? If this is something good to be learning at home, I would think, as long as you're paying attention with me. Okay, let's use mental math to complete this pattern here. So let's see, 9 times 5 we see is 45. So here's 9 times 5. We have to write down 45 times 10 to the first power means we just add that 1 0 because it's just times 10. 9 times 5, again 45, and add 2 zeros to the end. Go back and put your comma, 4,500. 9 times 5, let's write 45, and how many zeros do we add here? 3, very good. So it's 4,000 or 45,000. We have those 3 zeros from that number 1,000 here. The 10 to the third power, remember, is just a 1, and that 3 tells you there's 3 zeros, so that's the number 1,000. 45 times 1,000, 45,000. Number 6, and here's the deal, guys. If you want to stop my video and go ahead and finish and do this all on your own, just go back and check your answers with my video once you push play again. I'm fine with that because I think this is an easy schmeezy lesson you should be able to catch on pretty quickly. So if you want to, pause me. If you don't, if you're saying I still need to catch on a little bit, just stay with me. Okay, 3 times 7, of course, is 21. It's written up there for us. But 3 times 7 times 10 to the first power means we add that 1 0. That exponent attached to the number 10 says add 1 0 because you're just multiplying it times 10. This times 100, or add 2 zeros, so it's 2,100. 3 times 7, 21, and look how many zeros we have to add, 3. So it's 21,000 because you're taking 21 times 1,000, 21,000. Number 7, oh, be careful with this one. 5 times 4 is 20, and just like the one up above that we did, number 4, whereas 6 times 5 equals 30, we have to be careful here. If this equals 20, and let me box out that number 20 there, how many extra zeros are there? Good, so that means 10 to the first power. Good job. 5 times 4 again is 20, so let's block out this 20 here. And look how many extra zeros we have. So that means 20 times what number equals 2,000? And it would be 10 to the second power. Those 2 extra zeros means to have an exponent of 2 attached to the number 10, which is the number 100. 5 times 4 again is 20. So let's block out over here the number 20. That's what 5 times 4 equaled. And look how many extra zeros we have here. 3. So what does that mean for our place value? Our 10 system means 10 to the third power. Goody, goody gumdrops. We're flying right through this. All right, use mental math and a pattern. So that just means count how many zeros you have to stick at the end. 6 times 6, a doubles fact, 36. Times 10 to the first power means I add how many zeros there? Only 1. So 360. This would be 36 times 10. And of course, it's 36 with 1 0 to the end. Across to number 9, 7 times 4. I love when we know our math facts. 28. And add how many zeros to the end? 3. So 28,000. That would be 28 times 1,000. Number 10, 9 times 8. 72, good job. Times 10 to the second power means a 1 with 2 zeros, so you're multiplying 72 times 100 meaning I have to add those 2 zeros to the end. 7,200. Number 11, 4 times 3, 12. Good job. And how many zeros do I add? Those two. So 1,200 or 1,200. Number 12 is 2 times 5, which is 10. And although there's a 0 there, that just means that 2 times 5 equals 10. We still have to add those 3 zeros to the end to make it 10,000. Number 13, 2 times 8, 2 eighths. Of course, is 16 times 10 to the second power. That means I'm multiplying it by 100. We add 2 zeros, so 1,600. Number 14, 6 times 5, there's 30. Now be careful, that is 30, so I have a 0 here already. I still have to take it times 10 to the third power, which is the number 1,000, so I have to add 3 zeros to the end. 30,000. So 6 times 5, the quantity of 6 times 5, I say, times 10 to the third power is 30,000. The quantity of 8 times 8, doubles fact, 64. And look how many zeros. This is going to be a really big number. Add 4 zeros. 1, 2, 3, 4, 640,000. And lastly, number 16 up here, my dog Archie, he does tricks. 7 times 8 is 56. And again, I have to add 4 zeros. 10 to the fourth power means the number 10,000, a 1 with 4 zeros. So that means I have to add those 4 zeros. And it's 560,000. All right, for number 17, what does the product, that means the answer to a multiplication problem, of any whole number factor multiplied by 100, any whole number, any number. It could be 6, it could be 24, it could be 72. Any whole number multiplied by 100 will always what? It will always have 2 zeros. And what place value will those 2 zeros be in? Say, for instance, I take 5 times 100. Anything times 100? Well, I know that's 500. What place value are they in? The ones and the tens. Good. It will always have 2 zeros in the ones and tens places. In the ones and tens places. Ones, tens. Alrighty, now we're going to do page 32. We're skipping over 31. I didn't care for it too much. There are some good questions, but I mostly want to do these questions with you. Okay, now, if you read them over already, you're going to see that they seem a little challenging, but these are all sciencey. So if you want to be a doctor or a nurse or anything medical when you grow up, this is the page for you. I feel like I'm half Mrs. Weiner right now teaching some science. So here we're talking about our blood cells. We know our whole body is made up of cells, and our blood is nothing different. Our blood is made up of blood cells, okay? Blood is necessary for all human life, and we know that already. It contains red blood cells and white blood cells, okay? What the job of the red and white blood cells, they nourish and cleanse the body. Okay, so that's what the red and white blood cells do. They nourish and cleanse the body. And our blood also has what's called platelets. So it has red blood cells and white blood cells that nourish and cleanse the body. And they have platelets that help stop bleeding. So if you get a cut, say on your finger, it turns into a scab in a little bit, right? That's the platelets in your blood drawing to that place and kind of sealing it over. Those are called your platelets. They seal it up to create a scab so you stop bleeding, okay? And it says the average adult has about 5 liters of blood flowing through our body. Now, you know how big a 2-liter soda is. So it's 2 of those and another half of one. So that's a lot of blood in our body. So when you get a little cut and you bleed, you're not going to bleed to death because there's a lot of blood in you. Okay, so you can see the pictures there of the red and white blood cells and the little platelets. Okay, let's scroll down to number 25. Now, these are a little more challenging. That's why I'm here with you to do them together. It says a human body has about 30 times as many platelets as white blood cells. A small blood sample has 8 times 10 to the third power of white blood cells. So how many is that? 8 times 10 to the third power means 8 times 1,000, or just an 8 with 3 zeros at the end, right? 8,000. How many platelets are in the sample? So remember what it says. It has 30 times as many platelets as white blood cells. So what we're going to do here is the problem that I'm going to write here. Do you see that word times? That means we're going to times. 30 times, or multiply, 8 times 10 to the third power. Now we're going to, instead of put the parentheses around 8 times 10 to the third power, the easier way to do it, the commutative property allows us to move those parentheses. So let's take 30 times 8 first, okay? And I know that 3 times 8 is 24, and we just add that 0. Okay, so these two numbers together equal 240, and if we know what 10 to the third power is, I just have to add that many zeros to the end. So it's 240,000 is our answer. About how many platelets are in the sample? 240,000 platelets. So we could just write platelets there. Okay, the wording's a little confusing, but we'll get through this, okay? And if at any time I'm going too quickly, remember you can just pause. Okay, the next number 26 says basophils and monocytes are types of, this should be white blood cells. A blood sample has about 5 times as many monocytes as basophils. So I'm going to circle 5 times. If there are 60 basophils in the sample, 60 of those, about how many monocytes are there? So if they have 5 times as many monocytes as basophils, and there are 60 of those, that means I'm going to take 5 times, I see that keyword times there, 5 times 60. Oh, that's an easy schmeezy one. Take your whole numbers, 5 times 6, and write 30. And we just take that 0 and add it to the end. So that number is 300 monocytes. There we go. This isn't so bad. It's the wording that's a little confusing, right? All these big science terminology, all these medical terms. Okay. I'm not even sure if I'm saying them right. I'm just kind of pronouncing them as I go. Okay, number 27, lymphocytes and eosinophils are types of white blood cells. A blood sample has about 10 times as many lymphocytes as eosinophils. If there are 2 times 10 to the second power eosinophils in the sample, how many lymphocytes are there? So it's 10 times as much as this. So let's write it all together, nice and neat going across. 10 times 2 times 10 to the second power. If we keep out 10 to the second power and do that last, let's put in parentheses 10 times 2, which we know 10 times 2, 2 times 1 is 2, and add a 0. We know that 2 tens is 20. So let's put 20 times 10 to the second power. And we just know that we have to write 20 with how many zeros? 2. So that would be the answer, 2,000. And about how many lymphocytes? We have to write the label lymphocytes. About 2,000 lymphocytes. And I could put that about sign there because everything's about this, about that. Okay, number 28. An average person has 6 times 10 to the second power times as many red blood cells as white blood cells. So we have many more red blood cells than white. A small sample of blood has 7 times 10 to the third power white blood cells. So how many red blood cells? If there's this many times of this, that means I need to multiply these two groups together. This won't be hard. We could take 6 times 10 to the second power times our second number, 7 times 10 to the third power. Now what we can do is take 6 times 7 and then add up all those zeros, but let's just do it one step at a time since these two numbers go together up here. 6 times 10 to the second power, that just means 6, and add how many zeros? 2, so that's just the number 600. Over here, bring down your times sign. We have 7 times 10 to the third power, which just means put down your 7, and how many zeros? 3, so that's the number 7,000. And now I have to take 600 times 7,000. So I could easily do that. 6 times 7 is 42. And now I have to add up all the zeros between both sides. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Holy cow, this is a big number. Go back your ones period, put your comma. Go back your thousands, put a comma. And so we have about 4,200,000 red blood cells. That is a giant number of red blood cells in our body. Remember, cells are super duper tiny. All right, down to number 29. Kyle says that 20 times 10 to the fourth power is the same as 20,000, so it equals 20,000. He reasoned that since he saw 4 in the exponent, he should put 1, 2, 3, 4 zeros. Is he correct? Well, let's see there. Let's write this out again. 20 times 10 to the fourth power. Well, what whole number is over here? 20. So we need to write 20 first before we add those 4 zeros. So now let's add 4 zeros. 1, 2, 3, 4. Go back and put our comma. So what did Kyle do? Here's the answer. It's 200,000, and he only put 20,000. He forgot that extra zero in his number 20. He just put down the number 2 with those 4 zeros. A 2 with 4 zeros. But 20 is here, so we need to put the 20 first and then add the 4 zeros. All right, darlings, your homework for the day is pages 33 and 34. I even want you to do that very bottom problem. Okay, it's not hard. It's kind of similar to this kind of problem. Do your work. I have the answer key up to check your work when you're done. And I'm hoping to see you tomorrow. Bye, everybody. Have a wonderful, wonderful day. Bye-bye.